This is the Level 2 Calculus 2021 paper walkthrough, and let's get right into this. A function f is given by fx equals 4x cubed minus 2x squared take away 7x plus 4. Use calculus to find the gradient of the graph of the function at the point where x is equal to 3. So, function of x is described as 4x cubed minus 2x squared take away 7x plus 4. To find the gradient at a certain point, we differentiate this function. So to differentiate, we take the power, we bring it down, we keep the 4x, then take 1 of the power, which is 3 times 4x squared, and repeat the process. Take away 2, we bring the 2 down, and we still have the 2. Oh, actually, I might redo that. So we bring the 2 down, then we have 2x, and we take away 1 from the 2, which is 2x to the 1. For take away 7x, it's just x. If we take down the 1, there'll just be 1. So it's just that the x disappears, take away 7, and 4 plus 4, the number 4 is just a constant with no x terms, so it just disappears. We multiply this together. 3 times 4 is 12, so 12x squared. Take away 2 times 2 is 4, so 4, and x to the power of 1 is just x, and this is just 7. So we want to find the gradient of the graph of the point at where x is equal to 3. So we just plug 3 into here. So we want to have f dash of 3, which is equal to 12. Plug 3 into here, squared, take away 4 times 3, take away 7. This is equal to 12 times 9, take away 4 times 3, take away 7, which is equal to 108, take away 12, take away 7, which is equal to 96, 89. By the way, you can just plug it into your calculator. That is completely fine as long as you do not skip too much of the key steps. For question B, for the cubic function fx equals half x cubed plus half x, find the equation of the tangent to the curve at x equals 2. So, for the equation of the tangent to the curve at x equals 2, we want to find the gradient, since fx of half x cubed plus half x will look something like this, and this is just a graph estimate, and it might look something like this. So this will be a tangent is a line where it just hits the curve. So for example, this cubic graph is half x cubed plus half x, and we want to draw a straight line that just hits this cubic fx. So where this straight line just hits the function, we want to calculate the gradient. So I'll just get rid of this. So to find the gradient, we take the derivative. So f of x is equal to half x cubed plus half x. F dash of x, take the derivative. So we bring the 3 down, so 3 over 2, then take 1 off the power, so 3 over 2x squared plus, and the half x just disappears to half. F dash x is equal to half 3 over 2x squared plus half. Then we want to calculate if the derivative at x equals 2, so dash of 2 is equal to 3 over 2 times 2 squared plus half, which is equal to 3 over 2 times 4 plus half, which is equal to 13 over 2. So we calculated that the derivative at the derivative at x equals 2 is 13 over 2, and so the graph will have a tangent with a gradient of 13 over 2. So the equation for a line is y equals to mx plus c, where m is the gradient and x is the x-axis, y is the y-axis, or where if x is and c is a constant we need to figure out. So we know x equals 2, so we want to figure out what y is at x equals 2. So and y and fx are interchangeable for the most part, so let's figure out what y is at x equals 2. So f of 2 is equal to half, let's bring the question, half of 2 cubed plus half of 2. This is equal to 8 over 2 plus 2 over 2, which is equal to 5. So we know at x equals 2, y is equal to 5. So we know that 2, 5 is a point on the tangent. We draw this, so this cubic, let's just say this is where x equals 2, and this point is where 2, 5 is. This is not drawn to scale, but this is an estimated drawing. So, and this line has the form y equals mx plus c. So we know the gradient is 13 over 2, and the points 2 and 5, so we need to figure out the constant c. So let's plug in all these value numbers together. So 5, so we know that y equals 5, and gradient is 13 over 2 times x equals 2 plus c, which gives us 5 is equal to 13 plus c, which means c is equal to -8. So now we know the gradient and the constant c. So we now know the equation y will be equal to 13 over 2x take away 8. That is question A and B done. Question C. So the number of daily viewers for a new presenter on a video gaming streaming service can be modeled by the following equation. V is equal to -11t squared plus 528t, where V represents the number of daily viewers and t represents time in months. Find the rates of change of daily viewers with respect to t. So, with respect to t, when the number of daily viewers is 3,520, so v is equal to -11t squared plus 528t. So we want to figure out what t is, the value of t. So we want to figure out what value of t gives us 3,520 viewers. So let's plug in the viewers. V is equal to 3,520 is equal to -11t squared plus 528t. We can rearrange this to 11t squared take away 520t plus 3520 is equal to 0. So we can I think you can just plug this into your calculator and solve it. I'm guessing that is that is what is suggested on the marking schedule. So t is equal to 40 and 8. I guess another proper method will be if we divide all of this by 11, we get t squared take away 66t. By the way, you can just use your calculator for this. I'm currently using my calculator. 320 is equal to 0. Then t squared take away, oops, I missed. This is 48. We take away 48t plus 320 is equal to 0. 3 take away 40. T take away 40, t take away 8 is equal to 0, which gives us t is equal to 8 and 4. No, for 8 and 40, sorry. So we know that t is equal to 8 and 40. So find the rate of change of daily viewers. Remember, gradient is rate of change, and taking the derivative is just finding out the rate of change. So we need to take the derivative of this function. So v dash will be equal to, so we take the 2 down, so minus 22t. Then we take 1 of the power, so yeah, that is minus 22t. Then the 528t we can just ignore, take the t away. So v dash is equal to negative 22t. So the daily number of daily viewers at being 3,520 could be t equals 40 or t equals 8. So we need to plug either t equals 40 or t equals 8 into this equation to figure out the rate of change at when we have a daily viewer of 3,520. So we can v dash of 8 is equal to negative 22 times 8 plus 528, which is equal to 352, or v dash of 40 is equal to negative 22 times 40 plus 528, which is equal to negative 352. What is the maximum number of daily viewers that this new presenter gets during the first 48 months? So the maximum, to figure out the maximum, it is when the derivative is equal to 0. This is because, so we have v equals negative 11t squared plus 528t. This will be a parabola with something like this. When the rate of change or the gradient is equal to 0, this is when we have a straight line, and we can show that this will be a maximum point. So when the derivative is equal to 0, we have a maximum point or a minimum. You must be careful when you set it equal to 0, since it will either give a minimum or a maximum point. So from the previous question, we have v dash is equal to negative 22t plus 528. So we want to set v dash equal to 0, which is 0 is equal to negative 22t plus 528. 528 is equal to 22t. We divide both sides by 22, which will give t is equal to 24. But remember, we're not done yet. So when t is equal to 24, we'll have the maximum number of daily viewers. But this is when it has maximum number of daily viewers. We want to see what is the maximum number of daily viewers. So we need to plug t equals 24 into our original equation. So v of t is equal to negative 11t squared plus 528t. We found that t equals 24 gives the maximum, so v of 24 is equal to negative 11 times 24 squared plus 528 times 24. If we plug this into our handy calculator, we'll get 6,336. We'll go to the next page. This is the tough excellence question. The number of daily viewers for an experience presented on a video gaming stream service can be modeled by the following equation. V equals 1.6t cubed take away 130t squared plus 2,900t, where V represents the number of daily viewers and T represents the time in months. Once the stream reaches 10,000 daily viewers, it becomes monetized and the presenter earns money. If the daily viewership falls below 10,000, the presenter will lose this income and will no longer make money. Use calculus method to determine if the stream after it becomes monetized ever stops earning money for the presenter. So, firstly, this is a cubic graph. So, something to keep in mind with a cubic graph you might want to remember is that cubic graphs will, if the number in front of the t cubed in a cubic, so this is 1.6, if this is positive, it will be something like this, and if it's negative, it'll be something like this. You can just plug this into your calculator, graphics calculator, if you have one during your exam, if you are unsure. So we have a positive in front of the t cubed, so the graph looks something like this, and these two are the local maximums. So we need to figure out these local maximums and see what these values are. Since this will be a local maximum and this will be a local minimum, and if the minimum is greater than 10,000, we'll have the daily viewership will be, if the daily viewership of the minimum is greater than 10,000, we can say it for most values. So let's use the previous method to find our local maximum. V equals 1.6t cubed take away 130t squared plus 2,900t. So to find the maximum or minimum, we take the derivative. We did a few before, so we take the 3 multiply it in front, 4.8, take 1 of the power, 1.48t squared, take away, bring the 2 in front, 260t plus 2,900. And to find these two critical points, we set v dash equal to 0. 0 is equal to 0.8 t squared, take away 260t plus 2900. So we could just plug this into our calculators again. So plugging into our calculators, we have 4.8 negative 260 900. If you do not have the calculator, use the equation t is equal to negative b plus or minus square root b squared take away 4ac all over 2a to figure out what t is equal to. So we figure out that t is equal to 15.71 or 38.46. One of this is the local maximum or minimum. So let's plug in how much viewers each number gives. So v of t, this is the amount of viewers. So v is equal to 0.6 of 15.71 cubed, take away 130, 15.71 squared, plus 2900 of 15.71. This will be equal to, I'll plug this into my calculator. So this might take some time. This is equal to 19,678. So, and then, okay, I'll just write this out a bit more clearly. So v of 15.71 is equal to 19,678. V of 38.46 is equal to 1.6 of 38.46 cubed, 130 of 38.46 squared plus 2,900 of 38.46. Plugging this into our calculator will give us 10,264. So these are the maximum and minimum. So this is where this is 19,678 and this is 10,264. So once the streamer reaches 10,000 daily viewers, it becomes monetized. So they'll reach 10,000 viewers somewhere around here, and the will increase, then decrease, then increase. Then this will be the lowest will go. Then we'll keep on increasing again. So once this curve reaches the viewers of 10,000, by the way, this comes right from the marking schedule, it'll never fall below 10,000. And you might yes, you might want to include when it is increasing or decreasing, but this will, but on the marking schedule it says this will be fine. Question 2. The graph of a function y equals fx is shown below on the axis below. Sketch the graph of the gradient function y equals f dash x on the if dash x on the axis below both sets of axes have the same horizontal scale. So when the gradient is 0, when the gradient of this is 0, then on f dash x that will go through the point 0. So it's when gradient is 0 when there are horizontal, where we can draw horizontal tangents. So here, here, and here are where we can draw horizontal tangents. So this, at these three, we need to translate these at these exact points. So we need to translate this to 0 here. We need to translate this to 0 here. We need to translate this point to 0 here. Then, so this is a, and by the way, this is a quartic, and this, since this is continuously going up, the constant in front of the quart of 4 is always a positive, since this just keeps on going up. So then this, then the cubic and we're differentiating, so we'll get a 4ax cubed plus, so this function will be ax to 4 plus blah 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 blah, and the function when we do it, take the derivative will be 4ax cubed plus da 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 da. So for this, so this will be 4ax cubed where 4a is positive. So all we need to do is draw a cubic that goes through these 3 points. A positive cubic to be specific. So it could be something like this. This is a cubic. This is what a cubic looks like, so this is completely fine. The function f is given by fx equals 5 plus 3x plus 6 squared take away 2x cubed. At the point on the graph of the function where x equals 2, the gradient is negative 5. Find the value of c. So remember that if take the derivative f dash x is where shows what the gradient is at a certain point. So take f dash x. 5 just disappears, so we have 3x, 3 goes down, the x just disappears, plus cx. So we take the 2 down, so 2c, and then take 1 away from the x squared, which is x. Take away 3 comes down, so 8, then take 1 away from the cube, so f dash x equals 3 plus 2cx, take away 8x squared. So x, where x equals 2, the gradient is negative 5. So if dash is 2, we'll have 3 plus 2 times 2, take away 8 of 2 squared. So this is equal to, so 8 of 2 squared. So mine take away 8 times 2 squared is take 8 times 4, which is take away 32. 3 take away 30, so 3 plus 2 times c times 2 is 4c, away 32, which is equal to 4c take away 29. And at this point, where x equals 2, f dash 2, the gradient is negative 5. Negative 5 is equal to 4c take away 29. 4c is equal to 24. This gives us 4c equals 24. C is equal to 6. A cliff diver jumps up into the air above a cliff and then falls down into the water below. The acceleration is constant at negative 9.8 t squared. Negative 9.8 meters per second. The diver jumps up with an initial velocity of 2.8 meters per second. Using calculation methods, find the velocity of the diver 1 second after they jump. So basically we have acceleration. If we take actually no, we have a displacement, or s of t, if we take the taking the derivative, which is defined by d over dx, we have velocity of, we get the velocity, then we take the derivative again, we have the acceleration. Inversely, if we take the integral, if we anti-diff, we get velocity, and then if we anti-diff from here, we get the displacement. So just we know that acceleration of t is equal to 9.8. So we saw from before that taking the derivative of differentiating velocity will give us acceleration. So to figure out velocity, we need to anti-differentiate acceleration. Anti-differentiating is kind of doing the opposite of differentiating. So we have a t, since there's no t terms here, we'll add a t term, 9.8t, and when we're integrating or anti-differentiating, we add a c term, since there could have been a c term somewhere. So the diver jumps with an initial velocity of 2.8 meters per second. So initially, the diver has a velocity of 2.8. So v of 0 is equal to negative 9.8 of 0 plus c. This is equal to 2.8. So negative 9.8 times 0 is just 0. So c is equal to 2.8 meters per second. V of t is equal to negative 9.8t plus 2.8. Using calculus methods, find the velocity of diver 1 second after they jump. So v of 1, negative 9.8 times 1 plus 2.8, which is equal to negative 7 meters per second. The diver hits the water at a velocity of negative 22.68 meters per second. Find the maximum height that the diver reached. This, you may wish to begin by finding the height of the cliff above the water. This is quite a difficult problem. This is probably an excellence level. So the diver hits the water at a velocity of negative 22.68 meters per second. From the previous question, we know that velocity of t is equal to negative 22.68. Sorry, I'll just mute my Discord tab. 22 point, sorry, I got distracted. So velocity of t is equal to negative 9.8t plus 2.8 from the previous question. So the diver hits the water at a velocity of negative 22.68 meters per second. Apologies, that is my dog. Sorry for the continuous interruptions. Okay, I am back, so let's continue. So v of t is equal to negative 9.8 t plus 2.8. So let's figure out how long it takes for the velocity for the diver to reach the velocity negative 22.68. So negative 22.68 is equal to negative 8t plus 2.8. Negative 2.2 points equal 2.8, which gives us 25.48 is equal to negative 8t. This means t is equal to 2.6 seconds. So, and to figure out the displacement, or the height in this context. We need to anti-differentiate this function again. So h of t will be integrating negative 9.8t plus 2.8. So we raise the power, so t is equal to 2 to the 1, so we raise the power by 1, which is 2, then divide this by 2. Then we add a t onto our constant, and have a plus c. So the diver hits the water at velocity of negative 22.68 meters. This height is how high we are from the water. So how high above the water we are. So when we have the velocity of negative if we hit the water at a velocity of negative 22.68 meters per second, we'll hit the water. We will be hitting the water. The height will be equal to 0 meters when at the moment we have a velocity of 22.68 meters per second. So at 2.6 seconds we will have a height of 0. So height of 0 is equal to negative 9.8. Let's simplify this. Negative 9.8 divided by 2 is negative 4.9. Then we can insert 2.6 squared plus 2.8. 2.6 plus c. So this means negative 4.9 times 6 squared plus 2.8 times 2.6. Negative 25.844 plus c is equal to 0. This gives c is equal to 25.844, or if we round to one significant, two decimal places, it'll be 25.84. So height can be described as negative 4.9t squared plus 2.8t plus 25.84. So we figured out a function for the height of how high we are above the water. So the jumper is a cliff here, and we will be jumping off like this, and this is t squared, so this will be similar to a parabola. So we'll just maximize this function again to find this maximum point again. Wait, actually, we can just maximize this function. So v of t is equal to negative 9.8t plus 2.8. Instead of maximizing, actually the derivative of this is just, if we maximize h of t, so we take the derivative of h of t, this is negative 9.8t plus 2.8. Okay, I'll rewrite this as h dash of t is equal to negative 9.8t plus 2.8. When h dash t of t is equal to 0, it is a maximum, so negative 0.8t plus 2.8 is equal to 0. This gives 9.8t is equal to 2.8. This means t is equal to 0.286. So this is our max. This at 0.286 seconds will reach our maximum height. So we just plug in 0.286, which is equal to negative 4.9.286 squared plus 2.8.286 plus 25.84. This is equal to negative 4.9 times 286 squared plus 2.8.286 times plus 25.84, which is 26.2 meters high. It was quite a tough problem. A curve passes through the point 1 and 2.5 and has the derivative f dash x equals 6x squared plus 5x take away 1. Find the coordinates of the points on the curve. If y equals fx, where x equals 2. So let's integrate f dash x. So if we take the integral, okay, integrating is this simple, and we're integrating with relations with dx. So this is integral of 6. This is the symbol for anti-differentiating. 5x take away 1 dx. So we raise the power of x to the x squared to 1. Then we divide by 3 plus 5 x squared. So we raise the x to the 1 by 1 and divide by 2, take away x. Then we always have a constant. We have a constant in front. Let's simplify this. So 2x cubed plus 5 over 2x squared take away x plus c is equal to f of x. So f of 1 is equal to 2.5. So 2 plus 5 over 2 take away 1 plus c is equal to 2.5. Actually 2, this rewrite 2.5 is 5 over 2. We can cancel these two out since they are the opposites. So 1 plus c is equal to 0, which gives c is equal to negative 1. So, and we're not done yet. So f of x is equal to 2x cubed plus 5 over 2x squared minus x take away 1. F of 2 is equal to 2 of 2 cubed plus 5 over 2 of 2 squared take away 2 take away 1. This is equal to sorry, I'm just plugging this into my calculator. This is equal to 23. An electric scooter is traveling down a straight footpath. Its velocity t seconds after passing a sign is given by v of t equals 0.3 t squared plus 1 meters per second. How far is the scooter from the sign when t is equal to 3 seconds? So we need to integrate this function. So because anti-differentiating the velocity will give us the displacement, so s of t is equal to, so we raise the power by 1 t cubed, then 0.3 divided by 3 plus t plus c, which is equal to 0.1 t cubed plus t plus c. This velocity its velocity t seconds after passing a sign is given by v of t 0.3 t squared plus 1. And so if we are traveling, if we are moving, then we originally have a velocity of, initial velocity is 0. If we're standing in place, then suddenly we begin moving, our initial velocity will just be 0. So 0 is equal to 0 0.1, so 0 cubed plus t plus c, plus 0 plus c, since our initial velocity will just be 0, which implies c equals 0, so s of t is equal to 0 0.1 t cubed plus t. Then we want s of 3, which is equal to 0 0.1 of 3 cubed plus 3, which is equal to 5.0 meters. The diagram below shows the graph of a gradient function f dash x. On the axis below, sketch the graph of the function fx. So if this f dash x, where these 2 points where x equals, where f dash x is equal to 0, this corresponds to horizontal parts where gradient is equal to 0. I mean horizontal tangents where gradient is equal to 0. So this, we can clearly see this is a parabola, so it will be ax squared plus something something something, where, and we can see this is going down like a cave. So this number, this constant in front, will be a negative number. So if we integrate and get f dash x, go from f dash x to fx, we'll have x cubed a over 3x cubed plus something something something, and a over 3 will remain negative. And a negative cubic function will always look something like this. So let's translate this x equals 0 to somewhere around here, and let's translate this x equals 0 to somewhere somewhere like random. And as long as these two, actually let's move this down to like here. So as long as these two holds, we can draw a line from up here, go down, and it's a bit wonky. It can go down, and then put this as our maximum. So this and this will be our maximum points. You might want to draw this a bit more neatly, and this has recently becoming merit questions, so you might want to draw this a bit later. Two possible configurations of a house shape drawn below. A parabola shown below. A house shape is drawn as shown, where C is at 0, 9. A and B are points on the parabola y equals 9, take away x squared. E and F are on the x-axis. Find the height of the wall AF or BE when the area of the house shape is maximum. Justify that this is the maximum area. So let's break this up into this part, this little rectangle, and this triangle. And let's write a function for this rectangle. This length is just a point x. So this point will just be x, and this height will just be y, and this is x. So we have this x, and we have symmetrically going the other way, so this total length is 2x. It doesn't matter where we are, it doesn't matter whether it's thick at a longer part, this length is always a random variable x. I mean, can be any distance possible, and the area of a rectangle is just the base times height. So the base is 2x and the height is y. So area of let's just call area A of rectangle is equal to 2x times y. The area of this triangle is slightly a bit harder, but we need to use the information. C is at 0, 9. So this height, so area of triangle will be half base times height. So this base length is the same as this base length, so half times 2x. Then this y, or height, this is 9. So this total height is always 9, and we can take away this bit to get this height. Sorry, that got a bit messy. So height of this is equal to 9 take away y. So half times 2x times 9 take away y is area of triangle. So the total area total will be, so let's simplify this to x times 9 take away y. So the area total will be 2xy plus x times 9 take away y. A and B are points on the parabola. Y equals 9 take away x squared. Yeah, expressing this in terms of y will be the easiest. So we have where we have the expression y, we want to plug in 9 take away x squared, because we can just do this as those two are just equivalent. So 9 take away squared plus x times 9 take away x squared. So 9 take away 9 is just 0, so this cancels out. And this negative x squared is just x squared. So then let's just expand this out. 18x. Let's expand this out. Take away 2x squared plus x times x squared is x cubed. So maximizing, we want to take the derivative and set it to 0. So a dash is equal to 18. Take the 1 off. Take away 2x, then take the 1 off. And take it in front and take it off the power. So 4x plus 3x squared. Right. Right, half times 2x squared plus 2x. 9 take away x squared, so 2x. Right, sorry, I'll just check. Apologies, I am back. It appears I made a mistake. So 2x. So when I substituted, I forgot to have this x squared. This is why you always check your working. So 18x take away x cubed. Let's do this. So 18 to a dash 18. This is equal to 18x take away x cubed. This taking the derivative will be 18 take away 3x squared. And so we set a dash is equal to 0. So 18 take away 3x squared is equal to 0. Divide both by 3, so 6 take away x squared is equal to 0. This gives which gives us x squared is equal to 6. Taking the square root is x is equal to plus minus square root of 6, but we cannot have a negative area. That will just be impossible. So we cannot have negative area. So x is equal to square root of 6, or negative length, negative side length, or actually just having a negative side length will be here, but that will just be symmetrical, so it doesn't actually matter. So x is equal to square root of 6. So y is equal to 9 take away x squared, which gives us, and plugging in x will give us y equals 9 take away root 6 squared, which is equal to 9 take away 6, which is equal to 3. So the total area is 2xy plus x times 9 take away y. We can plug these numbers in to get the total area. So area is equal to 2xy plus x times 9 take away y. I'll rewrite this to be a bit more clear. 2xy plus x of 9 take away y. So plug in the numbers, which is square root 2 times square root of 6 times 3 plus square root of 6 times 9 take away 3, which is equal to, so 2 times 3 is 6, and we just keep the square root of 6 as it is. So 9 take away 3 is 6, and we keep the square root of 6 as it is, and we just keep the square root of 6 as like a variable, so we have 12 square root of 6. This seems slightly unfamiliar, but this is how we treat square roots. So we have proved that this is, although we found a maximum area, this could be a minimum area, but this is slightly dumb, but we need to justify that this is a maximum area. So for justification, we can do the second derivative test. What this is we take the second derivative of a dash, take a dash dash, and if a dash dash is less than 0, then it is a maximum. If a dash dash is greater than 0, then it is a minimum. So we take the second derivative of 18 take away x 3x squared. So a dash dash 18 take away 3x squared, so 18 turns into nothing, so it will just be minus 6x. And if we plug in x equals square root of 6, then a dash dash is equal to negative 6 square root of 6. This is less than 0, therefore it is a maximum. This is a possible justification for the maximum. You can also there are also many other methods, such as graphing a of x and seeing it as a negative cubic. There are many on the assessment schedule, but I feel this is the most efficient way. And yeah, if a dash, yes, let's continue. This is quite a tricky problem. I would not be surprised if this is in something like scholarship calculus for year 13s. For the generalized problem where the house shape is bounded by a parabola where C is at 0, 6, A and B are on parabolas D, take away k squared, E and F are on the x-axis. Show that the maximum area enclosed by house shape occurs when the area of the rectangular section ABEF and the area of the triangular section ABC are equal. So let's see. Although this is a bit of a weird problem, and I'm not sure whether this is worded incorrectly, but I'll go on that rant later. So, area of the triangle can be said, so this is on the x-axis. The point, so like before we label this x, and so this base length is 2x, and this height is y, and this triangle will be d take away kx squared. So this height of the triangle is what is d take away y. So area of triangle is 2x times d take away y times half, which is equal to x of d take away y. And area of total, and the area of rectangle is like before, base times height 2x times y. So area of the total is equal to x d take away y plus 2xy. We can plug in y equals d take away kx squared. X of d take away kx squared plus 2x of d take away kx squared. So this is I should write equals better. D take away d is 0, negative kx squared is kx squared plus 2xd take away 2kx cubed. This is kx cubed plus 2dx. It's just better to have the x outside. It just looks quite a bit more aesthetically pleasing. This is equal to negative kx cubed plus 2dx. So set this equal to 0. A dash t. Oh no. Sorry. No. This is a. This is still the area. So we want to take the total area and the derivative of negative 3kx squared. Take 1 down and then take 1 off, plus 2d. Then set a dash t equal to 0. Negative 3kx squared plus 2d equals 0. 3kx, oh sorry, that is a bit messy. Kx squared is equal to 2d. X squared is equal to 2d over 3k. X is equal to square root of 2d over 3k. So we found that where x is equal to square root of 2d over 3k, it will give a maximum area. It will give a maximum area for this whole thing. So if we plug this into our equation, actually, so remember y is equal to d take away kx squared y is equal to d take away k of square root of 2d over 3k squared, which is equal to negative 2 d take away 2d over 3, which is equal to d over 3. So area of triangle is equal to x times d take away y. This is square root of 2d over 3k times d take away d over 3. Just d take away d over 3 is just 2d over 3. Square root of 2d over 3k. Let's see. Area of rectangle. This is equal to 2xy, which is this is just so 2 times square root of 2d over 3k times d over 3. We can bring this d over 3 out here, which is equal to 2d over 3 square root of 2d over 3k. Hence a triangle is equal to a rectangle. So it's 2d over 3, and we just proved that these two are equal. So this is the whole problem done, and the whole paper done. So thank you for watching. Hopefully this helped, and see you all later.